pancreas. Here's the head of the pancreas. So this is the first curve of the duodenum. Head of the pancreas, body of the pancreas, tail of the pancreas makes contact with the spleen. Seeing it from this side, head, body, tail, spleen. Now, as you know, the pancreas is a dual organ. That is, it's an endocrine organ as well as a digestive juice producing organ, an exocrine organ. The exocrine production enters this long duct that runs along from the tail towards the head and empties into the duodenum. That duct is referred to, it's named after its discoverer, a guy by the name of Wirsung, W-I-R-S-U-N-G. So it's the duct of Wirsung, or if you don't want to remember that German guy's name, you can just call it the pancreatic duct. That's equally good. Okay, pancreatic duct. In addition, most of us, I think the books say 80%, have another small duct that comes off that major pancreatic duct called the accessory pancreatic duct. Just accessory duct is enough. And that empties in independently of where the main duct empties in. So this just empties in. The main duct empties in at a spot known as the ampulla of Vater, V-A-T-E-R. In German it's pronounced Vater. It empties here, and the interesting thing is that there's a little sphincter there. It's called the sphincter of Odi. I usually don't ask you for that. Capital O-D-I, again in Italian, I think, for a change, instead of the German. So the sphincter of Odi stays closed, except when food enters the small intestine enters the duodenum from the stomach. Then it opens up and lets a squirt of digestive juice from the pancreas get in here. It also allows some bile from the bile duct, from the gallbladder to squirt in. So the main duct from the gallbladder, the main bile duct, empties into the same spot, that ampulla of Vater, as where the pancreatic duct empties in. Okay, so you can see it from this side. If I ask you what this is, you have to tell me. I'll get to those ducts in a minute. And of course, you have to know the names of these ducts as well. In addition, on this model, we can see the plicae circularis, the circular folds. And one of the questions I ask on the exam is for you to name 3 ways in which the surface area of the intestines is increased. Of course, plicae circularis is one of those ways. That's the only one I'm going to tell you. Okay, so we have these plicae that I can ask you to label. We also have here, well, it's best seen from here. This blood vessel right here is the superior mesenteric artery. Let me see it go down and continue down here. Superior mesenteric artery. And that's going to set branches all over the upper part of the digestive tract. We also see our old friend, one of the first branches of the abdominal aorta off the aorta, the celiac artery, with its going up to the stomach, right? So the gastric artery, the splenic artery, and here, going up with the hepatic portal vein, is the hepatic artery. Okay? So we have the sup-mes, the celiac, the gastric, the splenic, the hepatic artery, and the hepatic portal artery. You remember that the hepatic portal artery, I said artery, I'm sorry, that's incorrect. Hepatic portal vein. The hepatic portal vein brings blood that has been absorbing nutrients from all over the digestive tract up to the liver. The liver screens that stuff, detoxifies poisons, processes things, converts some of the glucose into glycogen. It does a number of things to the nutrients that have been absorbed before it allows that blood to enter the regular systemic circulation. Because from here, It's going to go through the liver, and from the liver, it's going to go into the inferior vena cava, right back to the heart to circulate all over the body. All right, I think we